Okay, we need to discuss about the chapter number 14 in grade 8. That is again a different section in science where we explore about our home, that is this universe and the solar system, right? So still we don't know the width and height dimension of our home, but still we are learning about it, and we are in the planet Earth as Homo sapiens sapiens, but we cannot we cannot distinguish, or we cannot predict even the size of the universe that is really, 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 really large. Because we know about our solar system with our sun, but there are different solar systems in this universe, right? We only know about our system in that is also not in detail. We know about the other systems, but names, few details only. We don't know actually how these solar systems exist in beyond our solar system. What are the other solar systems and their composition, their planets, and all. Still, we are not fully aware of these things. So the research institutes like NASA are discovering and also researching on these points, right? And they are browsing it. Okay, so let's learn about our solar system then, right? So the key person or the leader here is Sun. Actually, there are, that is, we call that as a star, and there are a lot of planets, right, moving around the Sun, right? So let's learn how this works. If you just observe the night sky, even with your bare or naked eyes, you can see a lot of celestial objects. අභ්‍යවකාශ වස්තු නේද අපි කියනවා ගොඩාක් අපිට බලන්න පුළුවන් අපේ සාමාන්‍ය ඇහෙනොත් අපිට බලන්න පුළුවන් using our naked eye also you can see and observe these celestial objects. So what are they? Some of them we discover them as stars, some of them are planets, some of them are man-made objects like satellites and even jets and International Space Station like thing. There are a lot, right? Okay. Then actually people in the ancient time, they also curious and they were really interested in about these celestial objects that they saw, and they basically gathered a lot of information. They related to gods, and they were in in direction prediction and the direction discovery. When telling the directions, they were using that, and with our lives, it was also the existence of these things. Well, some have changed drastically, but most of the things are slowly changing, and every day that we can observe that. Okay, why actually they just use naked eyes in the initial age, but later they have introduced various equipments like telescopes, right? So if you use a telescope, you can see enlarged view of these objects, and there are telescope lens also for the cameras, and there are telescopes, right? Have you heard about the different telescopes that were introduced by different scientists in different era? So still these telescopes are in use, right? This is basically initially ancient people were looking at the stars, and I said they were telling a lot of things. They were predicting, they were telling stories, they were telling about gods, they were telling directions, they were forecasting the luck and all these things by looking at these, right? Anyway, later this has become a science discipline, right? People have explored, and now we can say astrology or astronomical science, likewise different fields evolved related to this, right? And actually we are kind of a small planet in this. You can see Sun. After that, the Mercury, Venus, planet Earth. You can see so it's a small dot. But Jupiter and Saturn, these are the leaders. But in order to balance the entire system, all are needed. In order to balance this system, all are needed. Okay, let's see how they are working, how this system is working. Sometimes you may have seen them in, so because there are like systems made, physical systems made for the educational purpose, where you can observe the entire solar system, right? How it rotate and how it revolute. Rotate is basically happens around its own axis. Here planet rotate around their own axis. Here the Earth is also rotating around its own axis, but there is a tilt angle. So we normally call that is 23 degrees. Likewise, there is an angle. Anyways, tilting, and it is rotating in its own axis, around its own axis, right? But it is meanwhile rotating. It is revoluting. It is moving in an elliptical track, right, around the sun. That is elliptical track, and so it is moving like this. Okay, number of hours it takes for a rotation. What is the typically what is, can you tell the number of hours it takes for the rotation?
24 hours.
Okay, number of hours that it takes for the revolution? Okay, tell me number of days.
365.
365 days revolution, as well as 24 hours rotation. So that is for the planet Earth, but for the different planets, the time vary, right? The different planets, time is vary. Okay, the time resolution of the planet is time taken by the planet to revolve once around the sun. That is the year of the particular planet. 365 days, 0.25, right? There's a 0.25 also. 365.25, but in a certain year, every 4 years. So there is a special year. So that is, it takes 366 days in particular time, right? That is basically known as. Okay, consider here. Have you seen these dancers? They are basically rotating. They are rotating and revolving. Dancers dance කරනකොට එයාලා කැරකි යනවා නේද වටේට යනවා ඒ ගිනිමැලයක් වටේට. හරි වගේ ඔය එක එක මේවා ඉවෙන්ට්ස් වල dance කරනකොට එයාලා කැරකි වටේට යනවා. Right? Then it is basically how the rotation and revolution happen. Right? Same time dancer revolute around the imaginary point of the stage. Right? Okay. I said this. There is a tilt. There's an angle. A planet rotates around its axis, but in the planet Earth, along with the planet revolves in the sun, and it is called orbit. What is orbit? This is axis. That is planet's own rotating axis. Then the path along which planet revolves around the sun, this one, the elliptical track, this is called the orbit. Right? Remember these words, axis and orbit. All planets have tilt to its orbital plane when revolves. What is that orbital plane? Orbital plane කියලා කියන්නේ අපි දැන් මෙහෙම තලයක් ගත්තොත් මේ ඇන්ගල් එක ගන්න මෙහෙමයි. මේ වගේ තලයක අපි දැන් පෘථිවිය කැරකෙන elliptical track එක යනවා කියලා. එතකොට මේ එකක් sun එක මේ ඉර තියනවා නම් මැද්දේ. Okay, here the planet Earth. The planet Earth is basically moving or orbiting, or let's basically this orbit, it's revolving in this level. Actually, so then to this level, there is an angle. So this is basically known as the angle. Okay, then if this is there, if there's a perpendicular one to this orbit, මේ orbit එකට ලම්බකව එකක් අපි ගත්තොත්, right? So that is called the orbital plane. Then the Earth has tilt of 23.5 degrees, the perpendicular axis of its orbital plane. Perpendicular axis කියන්නේ මේකට ලම්බකව තියෙන අක්ෂයට. ඒකට අංශක 23ක් ඇලව ආනතව තමයි 23.5. ආනතව තමයි පෘථිවිය ගමන් කරන්නේ. So there is a reason, right? So subplanets around most of the planets, right? They also rotate around the axis while revolving around the planet. For me, our subplanets, example, moon. Moon is moving, actually moon is also rotating around their own axis and revolving. Mercury and Venus, these are not having subplanets, but other planets are having subplanets. And see, all the planets, they are having different degrees of tilting, right? Tilt to the orbital plane. Mercury, and it's having the smallest tilting, and which is not having any subplanet. And then the Venus is also not having no subplanets, right? No subplanet, that is a speciality. But you can see the orbital plane is basically, it's a big angle. The planet Earth, Mars, Jupiter, Jupiter and us, so almost same, right? Then Uranus is having similar, somewhat similar, and then okay. So then 1 year in the planet Earth, right? 1 year in a planet Earth, and so similar time, Mars will take similar time, rotational time. Yeah, right? It's rotational time. Earth in days. Sorry, this is not the orbital time. I'll tell that later. So here, actually, planet Earth. So let's say 1 day to rotate. That is 24 hours. But when compared to the planet Earth, Jupiter, Saturn, Uranus, Neptune are faster. Right? They are moving faster in their own axis. But Venus, a lazy one, right? Mercury is also a bit lazy, but Venus is the laziest. So rotational time, it will take 343 days to rotate around itself. Then Jupiter will add it to දවල් කාලය සහ රෑ කාලය ගත්තම නේද? දවස් ගාණක් දවල්, දවස් ගාණක් රෑ. හැබැයි මේ වගේ එහෙම නැහැ. මෙයාගේ ඉක්මනටම දවල් රෑ මාරු වෙනවා. දවල් රෑ මාරු වෙන ඉරේලිය වැටෙන පැත්ත අනුවනේ. එතකොට මේ අපේ සාමාන්‍යයෙන් පැය 12ක් විතර ඉරේලිය වැටලා ඉතුරු 12 වැටෙන්නේ නැහැ. මේගොල්ලන්ට බලන්න මේගොල්ලන්ට ඊටත් අඩුයි. හැබැයි මෙයාට අවුරුදු ගාණක් රෙදි වේලන්න පුළුවන් ඉරේලියේ. ඒ වගේම අවුරුදු ගාණක් කරවලයි මේ පැත්තට. ඒක rotation, yes, it's very slow rotation. Which is the biggest? Jupiter is the biggest. It is fastest and biggest, right? And so we are this is how many million kilometers closer to the sun. We are 149 million kilometers, right? 149 million kilometers closer, but there are 2 planets closer than us. And some planets are really far away from. Okay, these are the planets that you can see. Then revolution time. Revolution time is basically the time taken to move on its orbit. So planet Earth, it's one planet Earth අවුරුද්දයි, right? This is in years. This is in days. This is in අවුරුද්දක්. හැබැයි මෙයාට මොකද වෙන්නේ? The revolution time is less than the rotation time. You can see it's very fast revolution. Yeah, වේගෙන් revolute වෙනවා. වේගෙන් යනවා ඉරවට. ඉරවට යා අවුරුද්දක් යන්නේ නැහැ. අවුරුද්දකින් භාගයක් වගේ තමයි කාලයකින් යාගේ රවුම කම්ප්ලීට් කරනවා. එතන මෙයාගේ ඉක්මනට වයස යනවා නේද? ඉක්මනට වයස යනවා. දවල් රැ යනකොට වෙලා ගියාට මෙයාට පොඩ්ඩක් වයස යන්න දවල් රැත් ඇත්තටම වෙලා ගියාට ප්‍රශ්නයක් තියෙද මේක ඔයාලා හදලා බැලුවම තේරෙයි. You can create this. Then you can see how exactly the noon and night because of the light, because it is revoluting, the rotating විතරක් නෙමෙයි revolute වටෙත් යනවනේ මෙහෙම රවුම. ඒ යනකොට තව චුට්ට එක වෙනස් වෙන්න පුළුවන්. And here the revolution time, it is like 1/5. 1/5 means within 2 months year completed. But here it will take, when it is away from the planet, it will take more time. Neptune, it will take the longest time, right? And you can see tilt is, I have already explained, number of subplanets, no subplanets for these two. We have a moon, Mars is having 2, and Jupiter 67. Oh my God, you can see it's a very large number. Right, let's see how they are working together. Let's see a video on this. Just give me a time. You see this explain the rotation and revolution of the planets. Just give me a second.
On its axis, and the period of revolution is the amount of time it takes the planet to revolve completely around the sun. Up first is Mercury. The Mercury period of rotation is 58 days, 19 hours, and the period of revolution is 88 days. A day on Mercury is almost 59 days on Earth. Venus, the period of rotation, 243 days, 16 hours, and it rotates retrograde, in other words, in the opposite direction.
Wait, there is a rotation video. I was searching for that. Just give me time.
The solar system came into being when resulting in a solar located in the host planetary are 8 planets. The planets are divided into 2 categories based on their composition.
Here, up to here, what you need to know is that basically these are the facts. These facts, no need to remember for the examination, but just remember the order of the planets. For the examination, that is important, the order of the planets. And so mainly these 4 planets you saw, these are basically made up with the solid metals and all. And there are gas and also ice. Right? The coolest one is this, and you can see the hottest one also. So these things are some important things that you can write down about the planets. Okay, write small. Write down the heading first. Write down the heading first. Phenomena and exploration of exploration associated with the solar system. Then write down this question. Write down a question. This is just to explore and learn. Find and compare composition, temperature, atmosphere, find out and compare composition, temperature, atmosphere, and gravity of the planets in the solar system. Composition, temperature. Composition means like you can consider the core composition. Temperature, minimum and maximum temperature. Atmosphere, වායුගෝලයක් තියෙනවද, හැදිලා තියෙන්නේ කොහොමද? Gravity, ගුරුත්වය එක එක planets වල වෙනස් වෙනවා. gravity of the planets in the solar system.
Okay, sir.
Okay. Because that is not there in the book, you can do that as a experiment, as a, sorry, not experiment, as a research. You can just go through these things. You can browse internet, search these details, then you have to compare. So here actually stereoform balls of suitable sizes to represent the planets and suitable paints in given colors, and you can see how they are visible to us. Sun is in yellow color, Mercury in orange, bluish green is the Venus, dark blue is the planet Earth, red Mars, orange Jupiter, yellow orange Saturn, and Uranus in light blue and dark blue Neptune. So these are the colors, and you can see the diameter. This is actually a comparative figure, a relative figure. So if planet Earth is 2 centimeter, you have to take half of that for the Mercury diameter, right? Diameter. Diameter. Okay. Then next one is, you can see the Mercury is half, and Sun is 15 times of that, and then Jupiter is 10 times of this Mercury. Likewise, you have to here Saturn is bigger because of the ring, but normally Saturn is smaller than Jupiter. Okay, then you have to create, and so this using the story form sheet, you have to cut the ring and all these things, and then create this setup. Right, please create this setup, and this is how the planets look like. You can color, and this is too. But my advice is, if possible, just use the orbit. Just create the orbit using ring. You can use for the orbit. You can use a wire or a cable, right? Wire or cable. Maybe you can use they are like a galvanized cable. In hardware, you can find that, and then you can create the this orbit. After creating the orbit, then you can place the planet there. This is also okay, but only problem is you cannot show rotation and revolution. But if you have created, if you have done this, if you have created this ring orbits using cable, then you can do the revolution part. Okay, so I'll show you a sample.
Okay, sir.
One you can see, and here this is one thing. Actually, I saw this, some of the students here are also doing this orbit for 8 planets, orbit for 8 planets. Okay, something like this. You can create the orbit, and you can make it by yourself, right? Make it by yourself. It's called DIY. DIY, right? So we use that, and so let me show that. This is drawing, right? This is drawing, but you can just create using wires. So let me show, still not this one. This is one thing that you can create. This is one model. This is not using the orbits, but this is just using some straws, and you can connect them. This one. Okay, this is actually a model that you can buy and use. This is a model you can buy and use. This is rotatable. In the middle, there are sun, and the other planets are also there. These are plastic. You can just rotate and see. So this is basically, you can buy this online. And another one that you can create by yourself is something like this. Just gear wheels and all actually not needed. Only thing is you have to create the planets by just using the cables. But if you can put the gear wheels, it is better, because when you are rotating this, when you have turned on this switch, these gear wheels are rotating. These gear wheels are rotating the planets in different speeds. Right? This is basically a model which you can use to show. This can be used in your lab to get an idea, but no need to develop up to this level. But at least for the hand movement, you can create this one. අතින් move කරන්න හදන්න. ඉතින් මේ විදිහට හදන්න පුළුවන් නම් හොඳයි. මේකේ motor එක දැම්මම මේ gear wheel වලින් එක එක speed වලින් යන්නේ. මේක මෙයා ඇත්තටම මේවා කරලා හදලා තියෙනවා. මේ වගේ මට්ටමකට හදන්න පුළුවන් නම් හොඳයි. මුලින් එච්චර ඕනේ නැහැ. In the first level, please create this for the hand movement. අතින් move කරන්න පුළුවන් වෙන විදිහට හදන්න. Right?
Okay.
මේක නම් මදි පුතේ, මේ ඔයාලගේ පොතේ තියෙන එක නම් ප්‍රමාණවත් මදි. This one is just to show the sizes and all. Okay. හැබැයි එකෙන් ඔයාලට revolution එහෙම idea එකක් ගන්න බෑ. But you can show the distance, sizes and all. That is the only thing that you can do. So this model, they have also given this model of solar system in the school laboratory. Do you have this system in your school lab?
Yes, sir.
You have? Oh, that's great. So then you can see, is it like working when you turn on this? Is it working? Working or the manual one?
Manual.
Right, okay. Manual one is there, yeah, that is true. But the working one, you have to create that using orange. Okay. You can see occurrence of seasonal changes. This is happening due to the revolution. You know the 4 seasons are there. What are the 4 seasons?
Summer, autumn, winter, spring.
Summer, autumn, winter,
Spring.
What are the differences in summer? What is the summer, which time, and what is normally summer for Europe, which time, and what are the differences that they experience? Yes. No need to tell the date, just tell the months if you can, like, remember. Some, or just tell, even no need to tell the months, even tell the changes in summer. What is normally there in summer? What's normally happening in summer? Yes. In summer, what happens?
සමර් කාලෙට ගස් ඇවිලා තියෙනවා හොඳට. ඕටම් වලදී ගස් වල කපාට වෙලා ඒවා මේ කියන්නේ කඩා වැටෙනවා. වින්ටර් වලදී හිම වැටෙනවා. එතකොට ගස් වල කොළ නැහැ. ස්ප්‍රින්ග් වලදී ආයේ මේ ආයේ සමයකට
ඒ ගස් වල changes in සාමාන්‍ය පරිසරය කොහොමද වෙනස් වෙන්නේ? ඒක මතකද? So normally these leaves are ready for the photosynthesis, you know that. But when it is like what happened winter, autumn, summer, spring. In the winter, yes, is it good time for is it good time for producing food, photosynthesis? Yes.
No, sir.
Why?
No.
Why? Yes. The sunlight. Sunlight. You can see the sunlight. Status of sunlight. It's not really falling. So yes, you can say, you can show, you can tell that in these different seasons, the trees look like this. That is basic thing. But normally, so not just the trees, you can say what will happen in each season, right? What will happen in each season? Winter, autumn, spring, summer. So which is called that season?
Winter.
Yes, there you can see snowing and all these things in that season, right? So basically, in the winter season, you cannot, most of the trees, they are not having the leaves, but the tree is still alive. But the thing is, tree is not doing the photosynthesis very well because it is low light season. Okay, then okay, so which is the hottest season?
Autumn.
Yes,
Autumn season.
autumn. Okay, so what else you can see in the autumn season?
Yeah.
Other than that? Yes, you have only studied about the tree changes in the trace, is it?
Yes.
Right, but basically these are different from location to location, but I'm referring to maybe countries like Europe, because location to location, why it is different? Because country like us, so we are in like this equator ni samake asanne ni. දැන් අපිට මේවා තියෙනවද? Do we really have these seasons?
No, sir.
No, actually we have, but the thing, we have rainy season, so different so dry season, rainy season, then you know, this various like wind conditions, rain conditions, storming and thunderstorms, those things are there. But normally these main 4 seasons you will not experience in that region. But when it compared to a country like Europe, or country in Europe, or country like Russia, right? So then you can tell what will happen in this season. Okay, so since you have not explored, I think you can do this homework, because this is different from country to country, right? This is different from country to country, because you cannot say the highest temperature in a country in an equator is autumn. That might not be correct, because for a country in equator, a country closer to the equator, so situation will be different from a country in northern pole or southern pole. Therefore, let's take let's do that as a small research, because if you browse internet you will not get that exactly, but if you browse internet according to the country you will get it. Okay, next question. So these are exploration questions. Compare 5 countries in different geographical areas. I can give the countries, but you try to select by your North Pole, country in the North Pole, South Pole, and near to the, or closer to the equator, then in between North Pole and the equator. Take another country, in between South Pole and the equator. Compare 4 seasons for those 5 countries. Compare 4 seasons for those 5 countries. That may be again vary from country to country. It may be vary. 4 seasons because a country in equator, so this happens in a different way, but country in the North Pole, South Pole, some other way. In between North Pole and equator, in between South Pole and equator, some other way. Therefore, we cannot always tell autumn is this in autumn. So autumn, because these seasons are not clearly visible in some countries, right? But if it is in the like ends in the poles, the seasons are really visible because it is significantly affecting. But for us, it is not that significant. But still there are minor changes, right? Still there are minor changes because in December, January time, we also feel this is like Christmas season. We also feel the temperature has go down. We can feel it, but in April like that, we can feel, oh, it has gone up. Right? Okay.
Okay, sir.
So maybe you can take country like Canada, country like Australia, country like Antarctica, Greenland, and Sri Lanka, maybe India. Just compare them. Okay. So then this is why there are 4 seasons. The reason is clearly visible here because why here, just take this side of the planet Earth. See, this is exposed to the sun and this is half away exposed and this is also part of this is exposed and part of this is exposed, and here you can see it is not exposed because of, not just because of rotation, because of both rotation and revolution. So that is the reason, right? That is why you can see these seasons. Okay, then another questionable thing. So you know the Poya days. There are 4 Poya days typically: full moon, Poya day, half moon. But so these other days you are not basically considering. අපි අර සිංහල මේවල නම් කියන හතර පොය කියලා. හතර පොය කියන්නේ මොනවද? පොය හතර මොනවද? අහලා තියෙනවද?
Yes, sir. පසළොස්වක පුරාටවක පසළොස්වක පවාටවක
Then so moon is not visible in one day, and that is basically not full moon, that is no moon, right? Then you have like half filled moon and half like erased moon, and also full filled moon in full moon poetry. That is how these occurrences of different phases, and there are some other phases also, but these are the insignificant considerations, right? How this happened? Because of again this moon is like it's also rotating and revolving, and that is of revolution, and because of rotation, so this is happening to the moon also. That is because the shadow of the planet Earth, right? Okay, so let's understand this. Let me draw this. Okay, assume you have, this is your sun and our planet Earth in blue, planet Earth, which is smaller than sun, and then you have moon, member of the planet Earth, that is moon. What's the color that I'm going to draw? Yellow. Okay, white, but it's not visible, no? Or let's use this one. It's not very good color, but let me. Okay, moon. Okay, when the planets are organized in this way, the shadow of the planet Earth is falling into the moon. ලොකු වලාකුලක් වගේ තමයි. දැන් අපේ හෙවණැල්ල හින්දා ඒක හඳට වැටිලානේ. Because of that, this moon is not like self-lighting device. It's not having lights in it, no. දැන් තාම හඳේ lights දාලා නැහැ. ඉස්සරහට මේක වෙන්නේ නැහැ. ඉස්සරහට පොය නැතත් හඳ පේනවා. ඇයි ඒ? The ලෝකෙ දියුණු වෙනකොට they had like Google had the project to start a solar power system in moon. Not sure whether they will do or not, but they have planned. They are going railing solar system. Then this shadow, you will not be able to see the shadow. Instead of that, you will see the lights. But for the movements, we are discussing this in 2023. But when you are an adult, let's say in 2043, you cannot tell the same story to your kids. Maybe by that time, the people have established civilization in moon. Then what will happen? Moon has lights. When moon has lights, if it is so powerful, then even in this Amavaka Poya day, you will be able to see the moon. But normally, in this natural phenomena, shadow of the planet Earth is falling into moon. Therefore, moon is not visible that day. But when moon comes to this side, maybe the corner or this side or this side, the shadow is not falling. Therefore, you can clearly see the moon. The full moon is where the full or maximum opening to the sun is visible to us. That is the full moon or the Poya day. So these are some occurrences or the phases. Okay, you can again simulate this using a bulb and story form. And see here, sun. This is moon. Where's the earth? This is the earth. The person is the earth. What do you have to do? You have to rotate the moon like this. Rotate yourself and rotate the moon. Then you'll be able to see the light is falling into half, then maybe quarter. Likewise, it will increase, and sometimes it will fully covered by your shadow. Right? You can experiment that by doing this experiment. You can get that, you can see that, you can experience that. Okay, Pute. So with that, I will wind up for today because you have a lot of tasks to do now. 3 experiments and 2 findings I have listed. So please go through that and find details and come to the next class. Before the class, if you can send the details, that is really good. Okay, then I'll stop from here. Good night.
Good night, sir.